Hello, everyone, and welcome to our workshop on creating a machine learning model for business users. Thank you all for joining today, and I'd like to invite you to take a look at the while you wait slide that is up right now. So during this session, you're going to have an opportunity to build a machine learning model, right through from data integration at the beginning, all the way through to model building and deploying the model, all using a visual interface. As we work through this, you're going to be using a tool called Dataiku for building this model. And the while you wait slide shows the instructions that you should have received by email when you signed up for the event in order to make sure that you have your trial account set up so that you're ready to go through and do that process. For anyone that hadn't already gone through and set that up, I'd invite you to start on that now. We're going to be starting with a little bit of a presentation, giving some background and context for the event. This should give you enough time to go through that setup if you haven't done it in advance, so that by the time that we start actually building the model, you should have your environment set up and ready to go. Okay. So once again, welcome. We're going to start this off with a couple of introductions to myself and Alex, who will be your host through the session. Then we'll be going through the actual setup of the models. So my name is Kevin. I'm a partner with Deloitte Canada. I've been here for almost 5 years with the Deloitte data science team, where I've had the pleasure of building AI and machine learning models for a variety of different clients in a range of different industries. I've been doing AI, working as an AI professional since 2003, when I started my master's degree at the U of T Machine Learning Lab. So I've been doing this for about 20 years now, and still enjoy every day when I get to do this sort of work. I've done a wide variety of projects and a wide variety of work, and I'm looking forward to going through with all of you today to have a chance to build a machine learning model using visual tools. I'll be providing some context and some business context and experience of building models like this for clients as we go through, whereas Alex, who will introduce himself to you next, will be leading you through the tactical steps of building the model. Alex, over to you.
Thanks, Kevin. So my name's Alex Gobolos. I'm a solutions engineer here at Dataiku. I've been in the analytics space for about the last 15 years or so. It kind of gets a little bit hazy there. I was a software engineer prior to that, but went on to do data analytics work, primarily for financial crimes analysis. So looking at fraud, anti-money laundering, and things like that as well, across a variety of different industries too. So banking, insurance, even government agencies as well. I've moved to Dataiku just because I really believe in the platform, and the fact that really as a data, well, let's say subject matter expert, to become a data analyst or even a data scientist using a tool such as Dataiku or any of the other visual tools that's available on the market at the moment, just seems like a very logical thing. And it's a fantastic way to leverage all of that experience that you've earned in your industry and put it into some actual practice and get some benefits from it as well. So really looking forward to leading you through this process, or this first introductory project here that we're going to build out today. We'll be going through that data preparation step, exploration, and then building the models and deploying, as Kevin has said. With that, I'll hand back to you, Kevin.
Thank you, Alex. This has been an interesting experience for me so far. The audio is not working on my end, so I'm not able to hear anything that you say. That's not too unusual for me, though. I am actually mostly deaf. I hear with the support of a cochlear implant, so I already had the live closed captions up, so I was able to read what you say, but I can't hear it. So we'll see how I manage to get through this as the presentation continues.
Hopefully it gets the Australian accent.
To kick things off and get us started, we're going to give you a little bit of an introduction to machine learning. This presentation was topicked as building machine learning model for business professionals. So we're not going in with the assumption that you have a good background or a deep background on what artificial intelligence, machine learning, deep learning, generative AI, and all these things are. We're going to start by giving you some context to this, the sort of context that we often provide to executives and leaders in companies when Deloitte is providing services, helping them build AI and machine learning models. The first slide that we're going to use to introduce this shows some context for what artificial intelligence is. there's a wide range of definitions of artificial intelligence. My favorite one is still one that I was given in my undergraduate degree in my first artificial intelligence course, which is artificial intelligence is whatever computers haven't done yet. The bar is always moving for what qualifies as AI. Every step that AI researchers and companies make to improve things moves the bar further ahead. People feel like we're getting closer to real AI whenever a big step is happening. And I'm sure you've all noticed in the news recently that there has been another big step taken fairly recently, which is moving the bar both for what people think is possible, and I expect will also move the bar for what people consider real AI even higher. It's been a gradual growth in terms of what artificial intelligence is over more than 50 years now. Artificial intelligence, broadly speaking, means using technologies to mimic or extend human functions. This can be reasoning, learning, planning, interacting. It can be anything from the computer-generated characters in a video game through to a chatbot, through to these more sophisticated large language models that are popping up into the news today. All of that is part of artificial intelligence. One particular type of artificial intelligence that has really gained traction in the last couple of decades is machine learning. Machine learning means allowing a computer system to learn from examples that you provide it, generalize from those examples, and learn by those examples to solve future instances of the same problem. This is what we're going to be exploring today, machine learning specifically. Now, machine learning can be used for a variety of tasks, from categorizing and classifying examples to predicting numerical values, regression it's called, and to clustering and grouping things together. These are some of the common machine learning tasks. What they all have in common is that they need many different examples provided in data that they will learn from and use to predict future examples that they get. The next category, which is a subset of machine learning, is deep learning. This emerged in the past 10 to 12 years. It's a collection of techniques that use artificial neural networks that are very deep, and deep in the sense of having many different layers. So large artificial neural networks fed with very large amounts of data in order to solve more complex problems. This is a class of machine learning algorithms that emerged around 2012 and really revolutionized the AI industry. The last one to be added to this chain, which really has come within the past 3 years, is known as generative AI, or large language models. These are extremely large systems, huge deep learning networks that are trained with enormous amounts of data. They're new, and as they've come out, people are starting to discover that this extra data in these larger systems can make them more broadly usable for a much wider variety of tasks. We've seen an evolution over the past 10 years of how artificial intelligence work is done, where for a small number of problems, such as computer vision and natural language processing, a small number of organizations are making massive investments in training these really big models, like this generative AI movement. On the other end of the spectrum, there are small problems, simpler problems that tend to use structured data data coming out of databases and tables, instead of the sort of free-form data of natural language, text, or images that would be used from generative AI. These smaller problems, these simpler problems, are the ones that we're going to be focusing on today. These are the sort of problems that every organization has and can build lightweight, simple machine learning solutions that can help to predict or to classify or to cluster or group different examples to improve outcomes, to improve business processes, to make an organization more effective, more efficient, better for the residents that they serve or for the customer base that they have, better for their employees, whatever it may be there. Machine learning is where we're focusing today. So that's a subset of artificial intelligence. We're not going as far as deep learning or all the way through to generative AI. Those would not be the sort of things that business users on their own would be able to build over the course of a 1.5-hour session, but machine learning models can be done, and that's what we'll be going through with you today. The next slide outlines a few different types of machine learning and AI models, of machine learning models specifically. So machine learning, again, means computers that learn from examples to predict the next example. There are two different fundamental types of machine learning. It's called supervised learning and unsupervised learning. Supervised learning means when you give the system examples to learn from, you tell the system what the right answer was. So if you're giving it a million different examples to learn from, you need to give it what the right answer was for those million examples, so that for the 1,000,001th example, it can learn from the examples you provided. These supervised learning problems come in two general classes or categories. One is known as classification problems, where you tell it what the right answer was in a qualitative way. As an example, for let's say, employee retention, hypothetically. The employee either stayed with the company or it didn't, one or the other. It's known as a binary classification. There are also multi-label classifications where, let's say you're trying to predict the type of flower that you have based on some readings and measurements, and maybe it could be an iris or a lilac or a daisy. 3 different labels, 3 different classes that you could be classifying based on data. The other general type, aside from classification, is known as a regression problem, where you're trying to predict a numerical value. A simple example of this is if you're a retailer and you're trying to predict how many of a particular item are going to sell from a given store in the next week. It could be 1, it could be 2, it could be 3,000. You're trying to predict a quantity there. Those are regression problems. These are also known as forecasting problems because very often you're trying to predict future values from past values. Those are the 2 general types of supervised learning. Unsupervised learning means you have a whole lot of different examples and you're trying to identify groups that tend to come together. A simple example of this could be if you have an organization that receives 10,000 emails a week coming from residents or customers or citizens, and you want to understand what are the core topics that they're discussing there. Finding a way to cluster these and discover common themes among them, grouping those messages together to discover common topics and outline those topics would be an example of unsupervised learning. You're not telling it what the right answer is, you're trying to extract common themes and central topics there. These are the 2 different fundamental kinds of machine learning, and the tools that we're going to be working with today supports all of these, supervised and unsupervised learning. For supervised learning, it supports both classification and regression models. Yeah. So these are the basic categories. You've always got a few elements to any machine learning project that you're working through. The first is the inputs. This is the data that you get in. In the scientific jargon, these are your independent variables. They're the data that you're going to use to try to make a prediction. The second part is the model. The model takes you over to the third part, which is the outputs, known as the dependent variable in scientific jargon. Essentially, you have the inputs, the independent variables. You're trying to predict the outputs, your dependent variables, or the pattern or segment that you've discovered in unsupervised learning. The model is what makes that jump from that input variables that you have to the output variables that you want. And that's what we're going to be doing today with you today, going with you from the input through the process of building a model and seeing the output that comes as a result. The next slide shows the tool that we're going to be using for this. The tool we're going to be presenting today is specifically designed to support building AI and machine learning models as a business user. It does not require any coding or programming to use it. The tool is known as Dataiku. It's one that we use internally at Deloitte and many of our clients use as well. So Alex is from Dataiku, and he's going to give you an introduction to the Dataiku platform. And he's going to start walking you through the process of using your instance that hopefully by now you've got set up and are ready to use to actually build the model. Alex, over to you.
Thanks, Kevin. So let's get started in the hands-on portion of the lab. And I'll just bring this slide back up again and leave it here for about 20 seconds. If people have not yet set up their instance, you should get to www.dataiku.com and follow either the Get Started or Start for Free prompt at the bottom. It will walk you through the process of registering and setting up an instance. There's not a huge amount to it. Essentially, it will ask you which location do you want to be in, and then it'll ask you to sign in or sign up. You'll see a pop-up that will come up. Just choose sign up, enter a password and your name, and click the go button, and you should end up coming to a launchpad screen like you see just here on the left-hand side. If anybody gets stuck, please post in the chat. I've got a couple of my colleagues monitoring the chat as well. Amanda and Craig are out there watching to answer questions from everybody. Okay, I'm not seeing anything in the chat, so I assume everybody's good to go. So with that, I'll also point out that one of the academy courses that we're looking at, or one of the courses in the academy, is very similar to the process that we're going to walk through today. It's a quick start program for data analysts. We also have more in-depth ones or less in-depth ones if you want to as well. So if you want to be more of an Excel user and just doing data preparation work, which is 80% of what data science is, you could do this. If you wanted to go into coding and MLOps processes, we also have courses on that as well, and how you can do coding in Python and how this makes it a little bit more streamlined for you. We also do have a community. If you've got any questions at all, feel free to post in our community too. So what are we going to do today? Today we're going to connect to and explore a bunch of data sets. So this is just the data that you're bringing in. Think of it like an Excel spreadsheet or similar to that. So it's tabular data laid out in a fashion that you'll be able to read it and understand what's going on. And we're going to use visual recipes. So a recipe is just a way of changing data in some way. Think cooking. So you'll be able to transform. So this is doing things like joining two data sets together, stacking it on top of each other, just manipulating it in some way, and cleaning the data. And so before you build a model, the data has to be in the right format for it. And we can talk a little bit about that later on. But it's best to do some transformations to make sure you're not dealing with garbage data. The way that modeling works is that you want to have it generic enough so that you can find the right answers, but not too generic that you can't find any answers at all. We're going to generate some dashboards. So this is equivalent of what you do in like a Power BI or a Tableau. And then we're going to build a machine learning model as well. Using that machine learning model, we're going to try and predict customer behavior. In this particular circumstance, we're looking at whether or not our customers are going to churn, meaning they're going to leave my company. So we're going to start with connecting and exploring. And Kevin, if you can hear me, or if you can't hear me, I'll make symbols like this.
Yeah. I can't hear you, but I can see you. And the closed captions were lagging. Thank you. And I see there is a question in the chat asking, what would be a data scientist's future job opportunities if all the process of ML is automated on platforms? Well, that is an excellent question, and one that we're actually going to go through today. As we go through this, you're actually going to see the use of what is closest to an automated platform as we go, and you're going to discover the role that a data scientist would still play as we go through this. The short form of it is that the modeling part of a data scientist job for these sort of things is actually a fairly small portion of the overall project. The majority of it is understanding what data you have to work from, making sure you frame the problem correctly, making sure that the models that are being generated by these automated tools are suited to the task, and then deploying and monitoring the use in production systems. So there's still a huge amount to be done there. Now, the first step in a data scientist's job on any problem is always to connect and explore. This means, first and foremost, connecting and exploring to the data that you have available and exploring it to understand what data you have access to, what it means, what the data quality looks like, is it usable? It also means connecting with the business team that's looking for the particular outcome and exploring the problem itself, making sure you clearly understand what the desired outcome from the model is, how it's going to be used, and what the output would need to look like for it to be usable to purpose. This is a core part of a data scientist's job today that is often overlooked. Failed data science projects are far more often because of problems with data or problems with understanding the actual business problem than they are with problems in the machine learning work as well. So the data scientist job is still going to be huge, and connecting and exploring will always remain a core part of it. Because to do science, you need to understand the problem that you're trying to solve, and data science is a form of science. So Alex, I'll turn it over to you to start talking through the connect and explore process with Dataiku.
Perfect. All right. So by now, everybody should have got to either this screen here, and they should be looking at something that looks very similar to this, or you've clicked on this Open Instance button, which will take you to a screen that will look like this, which will most likely be completely empty. Again, I can't see the chat at this time because I've got only two screens in front of me. But if anybody does have any questions, please feel free to reach out. Okay. So the first thing we're going to do is we're going to start by creating a project. So everyone should be able to see a plus new project button on the side in some way up here. So we're going to click on this and we're going to go to DSS, Data Science Studio Tutorials. And we'll click on this here. And then you'll see on the left-hand side, there's a quick start button. And we're going to go down to quick start. And we're going to go business analyst quick start tutorial. And we can click on this here. This is going to create a sample project for us to look at. You don't have to use the TMLS instance. You can use whichever instance you might that you have available at the moment. Just to that question in there. The first, I think, 100 or so registrants should have access to a TMLS one, but it doesn't matter. If you'd like to use your own personal environment or personal box, that's perfectly fine as well. Both of them will be available to you to use for at least a week. Okay, so this takes us into the project itself, and everyone should see something that looks like this. You've got the title at the top, you've got some description on the left-hand side here as well, and then you've got a to-do list of things that you might want to check off as you go through. Pretty easy to understand so far. If you ever get stuck or want to get back to this screen, you just have to click on the title here. If you ever want to go back to the main screen, click on the bird at the top here, and that'll take you back to the beginning. Just have to click back into the business analyst quick start to get here, and it should take you to the flow. If not, you can go from this screen and click back, go to flow in the middle here. So what are we looking at this point here? So we've got 4 different data sets. And as I said, a data set is just some data, like an Excel spreadsheet that you can have a look at as well. So we've imported those already. If you want to try importing some of your own later on, basically just drag and drop an Excel or a CSV file onto the desktop here, and you can double click into one of these and you'll be able to see the type of data that we're dealing with here. So we've got customer ID, birth, price first, item purchased, gender, and churn. So let's go back to the flow and bring some more data in and see what we can do. So the first thing we want to do is bring in some data from a spreadsheet that's online, that's hosted online at the moment. So I'm just going to paste a link in the chat. And you can just copy that link. You don't need to go to it. If you do download it, you can just drag it onto the screen and it'll upload for you. But what we want to do is actually go up to this plus data set at the top, go down to network. You can see the types of data that we can connect to here. There's also a lot of other ones as well. So if you want to do SQL databases like Oracle, if you want to connect to something like a Databricks or a Snowflake, we can do all of that as well. So we are going to click on the data set and then just paste this URL in here as well. So you can see here, I put my URL in, countrygdp.csv. And then we can click the test button. and we can go to preview and see what data we're dealing with. So it says we've got country and we've got GDP per cap in here as well. So it's all ready to be imported. You can see that at the top, it's given us a new dataset name called country GDP, and we can click on the create button at the top here. And we should be taken to a dataset page that we can look at as well. Okay. So from here, what we want to do is go back and just try and understand what type of data that we're dealing with at this stage from across our data sets. So we're going to go back to the flow, and then we'll have a look at CRM last year, so our customer relationship management database. So let's double click on this, and you can see here we've got some unique customer IDs, a bit of information about the customers, so when they were born in this particular circumstance, how much they paid for that first item that they bought from us, their gender, and are they or did they leave us last year? So we know this already. So this is going to be our target variable, and what we're going to do is pick or try and understand who is going to leave in the future. So who's the most likely to leave us over the next year? And then that allows us to think about what can we do to keep them here. And that gets into like a whole nother topic, but we can start doing things like marketing campaigns or discounts or reaching out to these people and seeing if there's some way that we can retain their business. So we start to get some business value coming off of this. So what we're seeing at the moment is just a sample at the top. We don't actually bring all of the data in because we don't necessarily need it. In this case, we're looking at the first 10,000 records. We just want to get an understanding of what the data looks like. You can click on this compute row count at the top, and you can see that as a maximum, we're dealing with 22,000 records in this particular circumstance. If you want to change this, you can open up or by clicking on the sample or the tab on the side here, and you can go through and say, actually, you know what, I'd rather be interested in a random sample, and you can update that sample, and you'll see the data just change slightly as we've gone through that full set of data and picked out something a bit more random rather than the latest ones. There's reasons why you would do this. Generally, if the data is organized or sorted in some way, we don't just want to get the latest data. We want to get a nice representative sample from across the spectrum of data that we have available to us. At the top here, we can see a quick data quality start. So it says, okay, based on what is in this field, we think it's some text, and we think everything is 100% okay. We're not having any missing data. Missing data is something that can change our model significantly. Likewise, looks like our birth date is a date format, and it looks like, again, all of our data is okay. If it wasn't, we'd start to see some things saying some red symbols or some gray symbols showing up here saying that the data, we might want to have a look at it and understand it. Okay. So from the top, we can also have a look at this data in a bit more depth. So we can click on the little arrow at the top here and go into analyze. So it's really important to understand the type of data that we're dealing with. In this particular circumstance, we're looking at customer ID, and we want this to be unique. So we want to have a reference back to that customer. If there's a lot of data for one single customer in here, we're going to need to do some kind of aggregation to make sure we've got that unique record that represents a person. So in this case, maybe we would have had the price of all of their purchases, and we just want to get the first one, or we want to aggregate it so that we get the sum of all their purchases, or maybe we want all of this data, as much data as possible as we have about this person. The more data you have, generally, the better model that you can build. And so that's why this feature engineering, which is coming up in the next step, is going to be really important. So in this case, it looks like we've got some unique data. It looks like a count of 1 is the maximum from across. So everything is unique here as well. We can click through and see, looks like We've got a lot of people that were born suspiciously on the last day, not even the last day of 1899, which might be, say, a default value that we might want to clear because it's going to throw off our calculations a little bit. If it starts to predict on everybody appearing that's 100 and something years old, that's something we might want to think about later on for clearing out. We can continue to scroll through, and then we can see things like the price of the first item purchased. And then we click on numerical, and you can see here we've got some outliers where some people have spent a bit more money than others as well. If we do want to get into a little bit more depth with some of this, we can also explore this from a statistical perspective. So to do this, you can click on the statistics tab at the top here and click on create first worksheet. And then we're going to do automatic suggestion of analysis. Oh, just so we had a couple of questions in here. Oh, yes. It looks like my HTTP got killed by the chat when I pasted it in there for some reason. Sorry about that. So yes, just have to have an HTTP :// to get that. So in this case here, we're interested in churn. So I'm going to select churn. And then it looks at correlation. So it says, okay, this looks like it's correlated. And gender looks like it's correlated as well. So we can select these ones. They might all be related. So we want to see how they're all related and what that data looks like. And based on this, we can have a look at principal component analysis, which is a way of minimizing the number of features. We can look at univariate analysis, which is what we're going to do. And then maybe we want to look at correlations as well. So we'll just select those and create that. And you can see here, univariate analysis just does some analysis of each of those pieces of data and says, this is what our split looks like. Almost got a 50-50 split. My company is obviously not doing very well. Half the people are leaving each year or last year. We've got more female customers than male customers by the look of it. We can change the filter if I want to run this over everything, but at this stage, I think just that 10,000 records is enough. And then we have price of first item purchased. It's treating it as a text field because it came in from a CSV. So I can convert it into a continuous or numeric field here as well. And now I can see distributions, means or averages, medians, or that middle value of the lot as well. Now, each of these I can take if I wanted to, and I can publish it into a dashboard. We're not going to do that right now, but if we wanted to monitor this over time, we could do this too. So once I feel as though I've got a pretty good understanding of the data that I'm dealing with, I'm going to have to move on and say, okay, looks like I should spend my time cleaning up maybe that price of first item purchased. I might want to include gender in my model. I've got a few other pieces of data back here. So birth, maybe I can turn that into something that's a bit more useful. It doesn't look like it's correlated at the moment, but maybe I can transform it in a way that becomes more user-friendly. And then I've got all those other data sets that I want to deal with. So how can I bring all of that together? And so that is where we're going to go for the next stage of the itinerary. And Kevin, I'll hand back to you.
Thank you. I reconnected and I actually have audio again, so I can hear once more. So. All right, so the next step of project is, again, a common and standard one that you go through in just about any data science project. Once you get your data in, it is often not quite in the form and format that you need. It also is often messy. For all of you here who are business users, I'm sure you've heard the story that we would love to be doing more with our data, but our data is a mess, so we can't do any analytics with it there. This is common. There's a saying that goes that every data science project is 90% data transformation and cleansing and 10% data science. That 10% data science, 9 of those percentage points are finishing up the data transformation that wasn't done before you started, and that last 1% is the real modeling part of it there. This is pretty common. Often the data is not structured in the way that you need to do the work. What this means is that very often the individual rows of data that you have are not the same thing as what you want to predict or group. For example, if you have a regression problem, you might have individual sales by hour, and what you're trying to predict is weekly sales. In that case, you need to do an aggregation first. You need to group together all the sales per week before you can start doing the forecasting that you want to do. There's other kinds of ways to transform the data other than aggregation. Sometimes you actually want to separate it out. Maybe you have a continuous stream of events where an event either does or does not happen in any given week, and you just have when the events did happen. If you want to predict whether an event will or will not happen in a given week, again, you need to transform that data and turn it into individual weeks with a label with each day. This sort of transformation and cleansing is necessary to move on to the machine learning project. As we mentioned at the beginning, a lot of the machine learning portions will be automated, but going from the business objective, the business problem, to a cleanly organized set of data to be used to do a prediction for that business problem will always require the data scientist effort there. And this is the transform and clean step. And with that, I'll pass it off to Alex to take us through the transform and clean step that we're going to go through here. Before we go, though, I would suggest we pause to see if there's any more questions around people getting access to the data and getting things set up, because this is sort of, if you miss that, then the rest of the exercise doesn't really work. So I'd suggest we go through and make sure that I see the questions were mainly around getting access to the data. Were there any others? It doesn't look like it, but I'll pause for a moment so people can type into the chat if there is any further questions you have around getting access to the data before we move on.
Thanks, Kevin. Yeah, so while we're waiting, the steps that we're going to do today, or as part of this session, we're going to go through joining some data. So combining data sets together, cleansing that data. So that just means getting rid of the bad data and trying to make it as nice looking as possible. If you ever go to an actual data set in real world, you'll find that the data is never quite perfect. Parsing the data. So this is a way of just transforming that data to make it a bit more usable again. So like that birth date, for instance, that we saw, how can we change that into something that is useful? Calculating new fields. So this is another part of the importance of a data science or data scientist being part of this process. If you are trying to build a model, a lot of it is hypothesizing around what's the best way, what's the best relationship, what other things might affect the outcome. So if I'm trying to work out if someone's going to leave my company, what do I think is the reason behind that? And can I build something out of the data that would be representative of that? So maybe it's region, maybe it's where they're living, maybe it is the last time that they purchased something or we gave them a discount, how much of a discount we gave them, their feedback from their previous purchase, did they receive 5 stars, 2 stars, 1 star, were they referred? All of these things we can start to build different types of data around. Handling outliers is something else. So because this is a model, if we throw in, say, housing prices in Toronto, and someone happens to sell their house for, I don't know, maybe Drake sells his house for $50 million, and everybody else is selling their house for around, I don't know, what is it these days, about $1 million or so. If we start to look at how that influences the model, because it's such a big outlier, it's actually going to drag up our average. And so we want to eliminate things like that from our model. So we're going to do some of that as part of this as well. And then we can do that visualization at the end too. So moving back over to the project here, we're currently sitting in this CRM data set. Now, I'm going to go back to the flow. You can do this also from the data set itself, but we're going to combine this with web last year. So I'll single click onto web last year. And over on the side here, you'll see what we call visual recipes. So these are the different actions that you can take. So there's some things that are as simple as syncing, like moving data around between data sources. So if I want to push data into Snowflake or Databricks or somewhere like that, this enables you to do that. Preparation we'll look at a little bit. Grouping, distinct, windowing is all just different ways of transforming that data. We're going to select the join with. And because it's web last year, so this is information from our web traffic, we're going to combine it with CRM last year as well. Now you'll see that Dataiku also gives you the option to choose where you want to store it. We're going to leave the defaults here, but we're going to change the name to training top here, or training data, I think we'll call it. And so usually when you go through building a model, you have some data that's got a known outcome, which you use to train the model on. So did people leave, did not people not leave? And then you've got some scoring data, which is the unknowns. And you want to say, okay, well, now I know how my model runs. I want to score some data to find out what the outcome or the prediction is going to be. So click on Create Recipe. And you'll see here that it'll pop up with a join recipe that says, how do you want to join your data? In this particular circumstance, we're going to click on where it says left join, and we're going to choose an inner join. And that basically says any of the overlap, just like in the picture, any of the overlap between the two data sets, that's what we're interested in. We don't want just one or just the other, we want both. So we'll click on inner join, and then we'll add a condition in the middle here as well. And you can see here it's identified that customer ID is shared across both of those data sets, even though the name is slightly different. And some example of what that type of data that we're dealing with is here. So we'll go OK for this. And then we'll just go down to selected columns. Because they're named different, it's decided to keep both of them. But in this case, let's just remove the other customer ID. We don't need to have two versions of the same data in here. Because it's an inner join, they're just going to hold the same data anyway. So with that, we're going to go and run it. And this will be running the first recipe for everybody. And you'll see at the bottom, it gives this warning here that we're going to do it on Dataiku. So we're going to do it in memory on DSS. We do have other options. If you want to run it in Spark, you can. Because it's a small data set, it's probably not much point. For people that aren't familiar with Spark, it's just a way of massively scaling out data. So if you're dealing with millions or billions of records, it handles it and distributes it across a lot of different computers, for want of a better word. You can also push into a database if we're dealing with a SQL table here instead. But let's leave it with DSS, and we'll click on the Run button here. And this should go through, and you should see a little job is running popping up at the bottom. And once it finishes, we should be able to see an additional data set at the bottom here. So I've got this Explore Dataset Training Data, and I'm going to click on that. And it looks like somebody else is as well. And now you see we've got not just the original data set, but we've got some extra fields that we brought in from that web prepare. So now we've got that IP, we've got pages visited, we've got a campaign field as well that we can start to play around with. So from here, that's exactly what we're going to do next. We're going to start to prepare that data and put it into a usable format for our model. So we can click on the plus symbol on the side, and then the prepare button here. I'll just wait a couple of seconds just to make sure everybody's job is finished. And we can call this training data prepared. That's fine. I'm going to click on the create recipe here. So now we can see the data, but what we can actually do is we'll see that we've got these steps on the left-hand side. And now we're actually going to modify that data. It's not just viewing it, it's changing it. And so the first thing is I want to get this birth date into a format that's actually usable. So it says, yes, we recognize from the layout that it's a date, but we're not quite sure if it's American or English or Canadian, which is a combination of the two, where it goes, is it day, day, month, month, year, 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 or is it hour, hour, or is it something else? So we can click on this symbol at the top, the little down arrow, and we can see that it's prompting us for an action of parse date. So let's try that. And it's going to pop up and say, this is the format that I recommend: month, month, day, day, year, 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 year. And you can see here, it's applying to absolutely everything in the data set. So it's a pretty good guess at the best format for it as well. You can also see that there's an option for day, day, month, month, or you can add your own custom if you wanted to override it and use hours and seconds or something like that. Here's some examples of what that might look like at the bottom. But we're just going to go use date format for now. And you can see it's created an additional column, highlighted blue because it's just been created. You can see it's added a new step over to the side here as well, called birth parsed. And that says, okay, now I know the format, now I know that's actually a date, and I know how to handle that as I go forwards. So birth is great, but what we really want to find out is something that's a little bit less specific. So let's try and turn this into age. So we're going to use this drop down again at the top, and we're going to do compute time since. And compute time since, sorry, I'm just checking the chat here. Yeah, $50 million is not too far off the mark. We've got this compute time since now. You can see it's using birth parsed, calculating the difference between that and now. And, you know, I'm not interested in days. Days is a little bit specific. Let's get into years instead. So how old is somebody? And to make that usable, just so in case someone else wants to see what I'm doing with my project, I'm going to call it age, because that makes sense to me, and that's going to make sense to other people as well when they come in and look at my project. Now you can see here we've also got some very old people as part of my customer base, and I'm not quite sure this is accurate. And if you recall, we did see that we had a lot of default values on this particular day. So 1899 can't be too many people. I'd be surprised if there was that many people in my clientele. So we're going to go back to the top of age, and we're going to analyze this again. And you can see here we've got the same view that we had last time, but now we've got these action channel or action box here as well. So it says, okay, not only can you just see that they're outliers, we can take action to get rid of some of those. So I can click on actions, and I can clip rows or clear rows. I'm going to clear those rows. So just wipe them out completely because I think they're default values. Outside of 1.5 of IQR, which is an interquartile range, it's just a way of saying, oh, between the 25th percentile and the 75th percentile, I'm going to use that to standardize my measure across everybody. So let's click on this here, and you can see that distribution changes, and it looks a bit more bell curvy, which is kind of what we'd expect to see. We can close that down, and then we can have a look and see that, yeah, we've added this option on the side here. We've set a lower bound and an upper bound as well, and we're choosing to clear them. Clip will just set everything to 104.5 if it falls above it, if you're wondering. So now we've dealt with all of that, we can go through and we can clear some of these out. So we can go out and choose birth. Let's get rid of that. We'll just delete it, and date birth parsed. We'll delete that as well. We don't need them anymore. We're just going to use age from here on. We've also got IP, and again, IP is very specific. That's pretty much locating you down to where you live, essentially. And it's saying, okay, this is great. It's good to have this information, but you know, maybe it's going to tell me if your family's going to churn. It's not really that interesting to me. I want to make it a little bit more generic, something that I can use in a broader model. So I'm going to go up to the top of IP, and I'm going to resolve the geo IP. And what that does is it processes this IP, and you can see it says, well, based on the IP that was assigned to you, I can work out pretty much where you live, which is very scary. But this is what we're going to do. And we're going to go through, let's just remove this prefix because I don't need a prefix in it. we're going to extract the country, and we're going to get rid of the country code. We don't really need that. And we're going to go down and get rid of the region and city. We'll keep the geo point and add the country code in as well. So, yeah. Let's see if it lets me do that. No, it's going to ask me to do the IP. I'm sorry. And so now when I click onto just a blank space, you can see here, these are the 3 columns that it's adding in here as well. So we've got a global group that's available to us here. So now we've got this, what we're going to do is just delete this IP again, because we're not going to use that in our model. So we'll get rid of it, just a little bit of tidy up. And we're going to add that other information that we had brought in from our web page. So that was from that HTTP link. If you don't have it, you can skip this step. It's perfectly fine. If you do, we can go to add new step, and we're going to do searching for a fuzzy join. Fuzzy join just means we put in some uncertainty. So in this case here, we're going to choose our IP country, and we're going to join it with this country GDP that we had before, which, if you recall, had 2 columns in it. One was country, the other one was GDP per cap. And when I click on this box, it's going to prompt me for that as well. It says, okay, join with what? Let's join with country. And what column should we bring in from that? Let's bring in GDP per cap. And you can see here it pops up. Now, I'm also seeing a lot of blanks here. And that's possibly because, if you recall, in the other data set, it was lowercase throughout, or it was missing maybe United Kingdom or United States of America was spelled slightly differently. There could have been some typos or something in there as well. Now, because this is a fuzzy join, we can put in things like spelling distance, or in this particular circumstance, we're going to do normalization of text. So we'll check this box here. You'll see that everything popped up now, so we're pretty good. Got a couple of missing ones still. I can hover over this and see that there's a few empties, less than 1%. And for now, that's going to be acceptable for me. So let's say that's fine, not a problem at all. And we can delete this join prefix this time, I'm sure. So we can get rid of that just to make GDP per cap a little bit easier. Now, alongside that, this is pretty much just going to give us the same value as what country is giving us, because I know that this is pretty unique, and country is also basically the same. It's very correlated to GDP cap. Maybe we'll get some binning and things like that in there, but we want to make it a little bit more generic. So what we're going to do is we're actually going to do a calculated formula, a little bit like you do in Excel. So we can scroll down a little bit on the left-hand side here, click add new step, and then we're going to search for formula. Second one here. And we're going to call this high GDP cap. And so this allows you just to type in formulae. So if I start typing, I'll get like an if statement here. It says it's valid. Open bracket is what I need. Now I need to put in a formula. So I'm going to use GDP cap. So if I type GDP, it'll prompt me and say this is what we should use. Let's say greater than 40,000. If GDP per cap is greater than $40,000, let's say that they're a high person, so we'll give it a 1 or a flag like a Boolean yes. If not, we'll give it a 0, which is a no. And there you can see you should get a sample output in there as well. And I'll just copy and paste this into the chat just in case. It's in here at all. And with that, I'm going to save it and apply it. And I'll see one more column appear. And I think I'm pretty comfortable with all of this. So we can all click run now, and we should see this executing. And again, if you missed a couple of steps, it doesn't matter too much. We just want to do something representative. These are the same type of things that you'll do as part of a data science project when you build it out yourself, coding or otherwise. We can explore this outcome as well. Based on this, we can do things like creating charts. So you can go up to a chart here and say, let's build something based on, let's go with age. So let's go age, drag it across the x-axis, churn to the y-axis, and you'll see we've got a nice distribution here, but for some reason it's chosen to give us an average of churn, and I'm really more interested in the sum. So how many people are actually leaving. Remember, 1 means that they left, so a sum is going to add up the number of people that have left. And so I'll start to see here, looks like I'm not doing great with the 40 to 50-year-olds, but they're also my biggest group of customers as well, if you recall from before. We can do some things to tidy this up as well, like checking these boxes here to adjust those bin thresholds or settings. And if you want to, you can start playing around and throwing in things like gender and seeing the split here as well. It looks pretty consistent by gender too. We can also use our newly created IP geopoint. So click on the plus chart down the bottom to make a new one. We can select a scatter map, and then we can drag the IP geopoint up to the geo box at the top here, and it's going to populate and show us where everybody lives. So that's that point that we created from before. This is strictly for reporting purposes. Now, if we wanted to map out with, say, churn, we can do this, and you can change the size of the bubbles and things like that as well, just by clicking on that symbol over to the top. I'll move it down to 3 so it's a little bit more visible. And if you wanted to, you can go in and change colors, and we change this like red to green. And you can set it if you wanted to for churn to be alphanumeric instead, so it's not a scale. And you can say people that are leaving, let's call them red. And I can scroll in and see how's Toronto doing. Yeah, looks like we're okay. We've got a few people leaving, but not a lot of customers there at all. But now I've created those. Again, as we talked about before, we can click on the publish button at the top here, and it says, okay, they're sampled. That's great. I don't need to show all of the data in these. I just want something representative. We can select them both, and we can click on the create button, and this will create a nice dashboard here that you can now drag around with as well. Once you've laid it out as you wanted to, you can click on the save button at the top, and then you can view your fantastic dashboard. And obviously you can keep going and adding different things to this as well if you wanted to, and exploring it as you needed. So once that's all done, the next step after doing all of this is where we're going to start building the machine learning models finally. So I'm going to hand back over to Kevin.
Thank you, Alex. So after all this work, we finally got our data in a state where we're ready to start doing the machine learning modeling. This is the fun part, especially for the data scientists. This is the part where you understand what the problem is you're trying to solve, what the business outcomes are that you're looking towards. You have a sense of what's going on in the data, what you have to work with, what fields are reliable and clean, which ones are kind of meaningless or empty. You've got your data transformed into the shape that you want to work with, which means that each row in your data set that you're working from is one example of whatever it is that you're trying to predict or classify or forecast or cluster and group together. Your data is ready for the modeling. This is the fun part. This is the part where the data scientists really get to spread their wings and try out different models, try out different sets of parameters or choices within the models, see the results that you're getting, see which ones work well, which ones don't, and make your decisions there. These automation tools, they speed this process up for the data scientist. but they don't replace the need for a data scientist to exercise judgment around which models are good for the particular purpose that you have, which models are working well, which are not, which types of models to use. This is the place where experience matters, but the only way to get experience is by trying, testing things out, and gaining the experience. And this is where Alex is going to lead you next, is going through the experience of actually building a model. So back to you, Alex.
Okay, so let's go to the next slide here. So this time we're going to go through and use visual machine learning to train the model, have a look at the results of that, iterate on it, see if we can change it, make it any better, configure some hyperparameters, and then retrain that model to see what we can do. So everybody should have a flow that looks roughly like this. Our data's come in, there's our join recipe. We created this training data. We did this prepare data where we did the fuzzy join back to country GDP. And now we've got a training data prepared. Might be called something slightly different depending on how you named it. So what we're going to do is we're going to click on the lab button. Once we've selected this, click on the lab button, and you can see here we've got different types of prediction that we can do. So you can go in and do object detection, image analysis, text analysis, forecasting, deep learning, all sorts of cool things. In this case, we want a prediction essentially because we've got a yes or no answer. So this is classification at its basis, or basics, most basic, that says yes, this person's churning, no, this is not churning. So we'll click on this auto ML prediction, and we're going to choose churn as our target variable. So that's what we're trying to predict. We've got a few different options. So based on the options that you pick and the type of data that you're dealing with, it'll select some models for you. We'll do interpretable models because we really want to understand what's driving people to leave. Is there something that's a good indicator for us that we might want to iterate on top of? So maybe if it shows us that country is something good, then there's a region-based thing and we can dive down and manipulate that data a bit more if we need to. If it's a gender thing, maybe there's something that we need to do that we can extrapolate on that in some way. So we're going to select this. If you wanted to play around with this later, you can go and look at deep learning. You can write your own models as well if you wanted to. You can get as deep as you absolutely need to. But for now, let's create this. And it's going to take us to a page that says, hey, we've done a design for you already. You're good to go. Everything's ready. This is the auto part of the auto ML, and we can just click on train. Now, it's done its best to guess at how good a model it can create and what features to use and things like that. And you can see here it's kicking through and it's going through various different hyperparameter or model settings. So it says, okay, I'll try this setting. Maybe I'll try this setting. Maybe I'll try that setting. And then based on the way that it works, it essentially tries to narrow it down to find the best model for us. And you can see here, it's done a pretty good job. It says my decision tree is my champion at the moment. And we can click onto this or click into it down here if you wanted to. And you can have a look and you can see what it did when it was training. So we've got a decision tree, and the decision tree is basically what you see here. It says, okay, based on GDP cap, is it greater than this amount? Then it looks like people aren't going to leave. So wealthier countries look like they're going to stay with me. Other countries or people from other countries look like they're going to leave me unless they spent over $90 on their first purchase, and they're a subgroup within that $34,000, and then it goes down and breaks down that GDP per cap, and you can see it looks like my campaign is not particularly effective at the moment. Maybe that's something I need to talk to marketing at. It's not really making a big difference whether or not people stay or leave. In fact, yeah, there's very little difference between the two once you get to this level. We do have things like variable importance built in. So this is also important to understand what to iterate on and what you might want to manipulate to make more hypotheses later on. So again, you can see GDP cap is something that's a really strong driver for us. Likewise, price first item purchase. So maybe we need to make sure that people spend more on their first purchase or add more things to their basket or something like that. age is coming down. Campaign, true and false is still fairly usable as well, but it's not a strong indicator at this stage. So we've got a lot of other things that you can explore. One of the best things, or the most usual things to look at, is a confusion matrix. And a confusion matrix that you see here pretty much just tells you how accurate your model is based on, if it was 1, so people actually left, and we predicted that they would leave, yeah, we're getting looks like about 20% of people in here, which is pretty good. And people that left and we predicted that they'd leave, actually it's way more than 20%. My math is terrible. It's about 50%. And we've got actually versus predicted. Yeah, we're getting pretty good results there as well. And so you can see here that total, we've got 4,500 records. Looks like we accurately predicted about 4,000 of those. So our model is really pretty good in this circumstance. We've also predicted that some people will leave when they didn't, and some people we predicted they'd stay when they actually left. And maybe these are the ones that we might want to get down on and really understand what went wrong there, depending on the type of model and the use case that you're working with. So if it's something like an application for a home loan to buy that $50 million house, maybe that's a bit more important versus maybe there's a fraud use case in there. And, if it's under $20, is that something we really care about? Maybe, maybe not. Do we block it? Do we let it go through and then let someone complain back to us that they've lost $20? Lots of different circumstances why you might want to focus on one bucket over another bucket in particular in this case. So on top of all of that, there are a bunch of things that you can explore at your own pace. Explainabilities, understanding the model, all of this. You can go through it and step through this as well. We also have checks for things like bias in here too, which is a pretty hot topic at the moment. So really understanding whether or not the model is treating everybody in the same way. And you'll start to see some of this under like some population analysis, where you can select something like a gender and put this in here, and it'll go through and say, yeah, the model works pretty much the same. It actually works a little bit better for the men than it does for the women in this circumstance. So maybe we need to go through and work out why that is. You can also see things like individual explanations. If you wanted to go through and compute like what they call ICE or Shapley explanations that go through and say, this is the reason that this person in particular is leaving. Maybe you want to do something specific about that as well. So now I've had a look through this and I've got a good understanding. I know that GDP is something that's driving it. I might want to go back and clicking on the models here again. So we've got models on the side. We can go into the design of this model and see exactly what it did. So this is all of the stuff that you would typically do through something like a scikit. And in fact, scikit is the models that are running underneath all of this. So it's saying we've got a 2-class classification, predicting churn. It's about a 50-50 split of yes and no's. We're splitting this up by taking 80% of it and using it to train, and the rest of it we're using to validate that the model's working. We do have some things in around debugging and sanity checks just to make sure there's nothing like what's called leakage, which says I'm using a variable that's already telling me the answer. So, maybe if it's fraud, there's a field in there that says the customer's complained about fraud, which is kind of useless, or it's been under investigation. So we can go through and check for that as well. Features handling shows us how we're actually handling each of these. So you can see here it's rejected the customer ID because it's unique. It's not going to be useful for predictions upcoming. It's included IP geopoint, but maybe we want to turn that off because this is very specific and it's not something we need. So we can turn that off. Something like age, we've got imputation where it fills in blank values and it just says, let's set it to the average so it doesn't disturb it one way or another. It just kind of nullifies the effect of that in there. You've got a lot of different options that you can choose from within here. For now, we're going to go down to the algorithms tab. Let's turn off our decision tree and our logistic regression, and we'll put in XGBoost, which is a different type of model again, and we'll put in a random forest here too. And you can see what we've got as hyperparameters. It says, how many trees do I actually want to build? In this case, we're putting 100 different decision trees and averaging them out. But we can try putting 50. And again, this is where data science becomes a bit more artsy. And it says, okay, based on what you think, the type of data that you're dealing with, what your feel for the type of, the number of different variables you want to use, you can throw in some variables here and see exactly what you want to include. And so you can just throw in some values. It's up to you what you put in here. You can do a range if you prefer. And it says, I'm going to try anything between 1 and 20. It's just different ways of setting stop limits on your model when it goes to build through. And you can do a whole nother session on how a decision tree or a random forest works, but we're not going to do that for now. Once you've filled in some values and you're comfortable with this, you can click on the train button at the top again. It'll save it and it'll go to the training side of things as well. And then you'll start to see whether or not you get an incremental improvement over the last one. And you can see here, we're aiming for an area under curve, or AUC, of greater than 0.945, which was what our decision tree was. And you can see it trying all of those different hyperparameter options as it goes through. And it looks like we've got some pretty good results for the gradient boosted tree here, almost perfect in what it's picked. Once we've done this, we're going to select a model and deploy it. But I'm just going to hand back to Kevin to lead us into that section.
Thank you, Alex. So now you've had a sense of what it looks like to train a machine learning model using this particular tool, Dataiku, which offers a highly visual way of doing that. No need for coding there. As Alex showed you, it'll give you defaults, and the defaults will give you reasonable performance a pretty good fraction of the time. Yeah. So as a business user, as you get started using this, you're likely going to want to use the defaults most of the time in order to explore different models, try different things out, and get a sense of what can be done. If what you're working on is a well-formed problem, so you've transformed your data correctly, you've got one row being one example of what you're looking to predict or classify or cluster, and it's a solvable problem, then the defaults will usually give you reasonable performance. There's often opportunities for doing that hyperparameter tuning, so making different choices around which models to use with which parameters that can improve the performance. But for a lot of problems, that first step that you get will often be good enough to achieve your objectives, or at least as a starting point. But once you've got this model trained, this is where you need to actually move to doing something with it, which is another place where a lot of data science projects fall flat. They'll build a proof of concept where they've built a model that's able to predict or classify something that would be useful to the business, but they don't have any good way to deploy that model and build it into business processes, have it run on new examples. You can't run it, you can't use it. This is the last part, which is once again visual using this tool. Yeah. And we're going to turn it over to Alex to show you how you can take this model that you've trained and now deploy it into a production environment and automate the operation of it. Alex.
Okay, thank you. So we're going to do exactly that. We're going to take that model, deploy it, which means we're taking it out of that workbench place and putting it onto our flow and making it usable to score against this year's customers to find out if they're actually going to leave us. And let's hope not. And maybe we can take some action against them afterwards, but that's a whole nother session. So we're going to go back in here, and I see that XGBoost is my winning one. If someone else wants to try a different one, you're more than welcome to, but I'm going to click on my XGBoost, and I'm going to click on the deploy button at the top here. And what that does when I click on create is it's going to add that model into my flow as well. And so now I've got a model here. I can start to use it to score, but in order to be able to score data, you have to have some new data, and it has to be in a format the same as your old data, which means essentially we have to take this year's and combine them and then do the prepare steps that we did for the previous one. And so we need to get it into that exact same format so it can run through. So the easiest way to do that is just doing a control select like this to pick those two recipes out. And we're just going to copy them Like, why redo it? I don't need to redo it. Let's copy this subflow. And I'm going to go copy to in the bottom left. And you can see here it says set my target to the current project. That's great. I'm going to rename this to scoring data prepared and scoring data. And so I'll have 2 new data sets that have been created out of this to replace that existing ones, but I'm going to switch it over to use a different source. So when I click on copy, you can see here it's created a nice jumbled mess for me because it's still referencing that web last year and CRM last year. Now I want to replace those. So I can go into my recipe here, that join recipe at the top. If I double click on it, you can see when I hover over web last year or just underneath it, I can actually replace that. So let's do that. And web last year needs to be replaced with web this year. Place data set. And then likewise, CRM last year needs to be replaced with CRM this year. Now you see it says, oh, there's an issue. There's no column churn. And that's because for this year, we don't know if people are going to leave us yet. And that's what we want to try and predict. So that churn column doesn't actually exist. We're going to build it ourselves using our model. So I'll click that replace data set. And I can click on run. And it says, okay, we had 8 columns before, now we've got 7. Let's just update that and run it through. And while it's doing that, we can go back to the flow here. And you can see here, now it's separated everything out nicely, feeding into my prepare recipe. I'll just refresh the screen and you see it populated. And likewise, I want to build this scoring data prepared because that's what I'm going to use to score. So I'll just click on the build button and build that data set. And it'll run through and build that. So now when I look at this data, once it pops up and tells me that it's finished, there we go. I can see that I've got that data in the exact same format, and I've got this empty churn here that I'm going to score instead. So to score, we can go to predict, or you can even control or shift select the 2 fields, and it's going to limit what we can actually do. It says, okay, now you can only score or evaluate. Evaluation just allows us to see essentially how this model is performing over time. So is it degrading? Is the data changing slightly? Is the outcome expected changing slightly? And we might want to retrain this model because models over time, they'll become less effective. And that's something that we would discuss in an MLOps discussion. So let's just score this. And you should see input data set, scoring data prepared. And we're going to try and use that predict churn binary model. And let's just call this scoring data scored, just a little bit shorter. And we'll create that recipe. It's going to give us some options. If we want to override some of the settings, change backends, all of the rest of it, let's just leave that as it is. What I will do, we'll output the probabilities as well, and we'll run that through. You can see you can also output explanations. It takes a little while, so I won't do it during this session. So that's going to go through now, and it says, okay, I'm taking my model, I'm taking this new data, and I'm going to work out whether or not people are going to leave. And then as I go across to the side here at the bottom, we can see now we have a prediction, and it says, this person, I predict that they're going to stay. And this person, I'm really confident they're in the 90.98 probability that they're going to leave. Really high probability that they're going to leave. Maybe some of these marginal ones, I might want to go out and approach and say, here, maybe I can flip you from a yes to a no, or a no to a yes, as the case may be. So we can start to take action on these as well. And so now we have something usable. We can put this into, say, a dashboard or a report, send it out to our marketing team or our call center or something like that and say, hey, these are the probabilities. These are the top 10 people that are, closest to leaving or staying, they're in the middle there. I want you to reach out. I want to give them a 20% discount or a 25% discount or something like that on their next purchase. And so we can try and keep those people as much as possible. So once that's all done, I want to run this more often because I want to make sure that I've always got the latest data, and I want to know every day or week or month that what I'm taking from here is going through this process, getting scored, and it's giving me something tangible to make decisions out of it. And so this is where we go in and we create scenarios or automation. And it's what you would put into a production environment. So I don't have to sit here and hit the go button every morning or push the refresh button for data. So to do that, we can go up to the play button at the top, down to scenarios. And there's no scenarios yet, so let's create our first one. And we'll do it with a sequence of steps, and let's call it score new data. That's good enough. Call it whatever you want. And we can click the create button here. And you can see here we can set it to be automated, and you can add triggers. So it says, do I want to do it when new data arrives or my SQL query changes? So maybe I'm querying for current date or date of last entry or something like that. After something else is run, or write some Python code. At this stage, I'm going to go a time-based trigger, and I'll set it to run, let's say every hour, starting from, strangely enough, around now. And if I wanted to, I could throw in some emails or Slack messages to tell me that it's done, to give me the results, even the dashboard itself if I needed to. I haven't set up a mail forwarding thing on my site yet. If you want to, you can do it on your own later on. You should have admin access to be able to do that and set that up as well. And we're going to go to steps. And you can see here, you can add a whole bunch of different steps to do. So in this case, we just want to build. And we're going to build that one data set right at the end, which is saying, I want to run my score recipe. That's all I want to do. Every hour, I want to get the latest set of customers that's going to leave me, and I'm going to take action on it. So we'll go into scoring data scored, click OK, click the add button, and now that's going to run through, and it's going to pick all of the required data sets. So if something has changed, if new data has arrived, it's going to rebuild it. If not, it's going to say there's nothing that I need to do. And so based on this, I can click the save button. And then if I want to test it, we can click the run button at the top here as well. And it's going to run through. It's scored some new data. I can see the history for that. Started with a manual trigger. You can see graphs, and you can monitor this over time to say, hey, how's it running? When's it running? Did it fail? How long did it take? All of these kind of stats over it. And so you can get an updated dashboard, all of those cool things that happen, in this case, every hour. Yep, yeah, it has integration with data residing in a cloud platform. So you can connect Dataiku into pretty much anything that is accessible from where it's being hosted. So if you've got access to GCS or AWS S3 buckets, then yeah, you can certainly do that as well. Likewise, if you're using something like a Redshift or Synapse or whatever, you can use those as engines as well.
Worth noting that in the case that you're using a relational database of any sort, connecting to the data that's stored in there, Dataiku actually pushes the workloads down to that database. So it doesn't actually pull the data out, transform it, and then write it back. It just sends the transformation instructions over to the database in many cases. So it doesn't just have integration to the data residing in cloud platforms, it can even push the workloads down to those cloud platforms as well.
100%. There's a ton more functionality, lots of ways that you can extend the platform and make it your own. You can create your own recipes and things like that if you really want to. So much to talk about in terms of like evaluation and deploying and creating APIs, but we've got 5 minutes left, so I don't think we're going to have time to cover it. But if there are any questions about anything data science related, Dataiku related, please let us know.
All right. Thank you, Alex. And thank you for everybody for joining in through this session. I know it can be difficult to follow along through a live session and do a workshop in a short time frame, especially on a remote workshop when it's not easy to just put up your hand and say, wait, I didn't follow that. What can we do? The session has been recorded, and if you've set up your free trial account, that should be open for 14 days, I believe, Alex. Is that correct?
Yep.
So you have plenty of time to go in, follow the recordings if you'd like, to run it and pause it at your leisure, try doing it, play with it, explore what you can do with the tool. And if you find that it's interesting, Alex and I are always happy to have a chat around what you can do with it and how either of our organizations can help you. We've still got some time for a few more questions, I believe. So if you have any, then feel free to type them into the chat and we'll answer. Otherwise, enjoy the rest of the summit.
I will also point out that we do have certifications on the Academy as well, if you want to go through those.
All right, so Alex and I will hang around for a few more minutes if anyone has any questions. And if not, then, as I said, enjoy the rest of the summit. Thank you, everyone.
There's one question in the chat. Can you integrate it with another system user? Yes, you can. You can integrate it with pretty much anything you'd like. You can add Python code at the end to connect to something. You can have multiple people working on a single environment at the same time as well, where you can communicate and send messages and things like that. If you wanted to push it out to an API, you could do that, and they could query the results. So if you want to do real-time scoring, that's certainly possible. Or if people just want to use, say, the model itself. So if I go back into Random Forest, I can put like a what if analysis and publish this on a dashboard, and people can say, you know, what happens if I put a campaign out to them? Will that affect the results? By the looks of it, my campaign is actually more likely going to make people to leave. So I really need to find my marketing team. Likewise, you can switch anything. You can kind of switch. You can play around with it here as well. So you can make that more real time if you need it as well.
As a user of Dataiku, I've found two different ways to integrate it into other system users. One is, as Alex mentioned, you deploy a trained model as an API so that you can call that API with new data sets as they come on an ad hoc basis. So you can score a result as it comes in to get a real-time recommendation back from the API. That's one approach. You also asked about warnings. So warnings I've generally set up using the monitor node, where you can set warning actions to trigger when certain things happen. And this could be a pipeline failing to run, or it could be getting certain results from the end of the pipeline, or loss of quality. There's lots of different situations that you can use to trigger events. And I believe, Alex, there's a pretty wide range of different events you can trigger, such as email messages or other automated messages that go through there.
That's correct. Yeah, you can send all sorts of communication, or you can run some just Python code. For explainability of linear regression, there's another question in the chat there. Yes, so you can go in, you can look at coefficient analysis, partial dependence plots as well. So if I wanted to have a look and see how age affects the outcome over the range of age. So partial dependence basically holds everything static and says, okay, now what happens when I vary age? Oh, it looks like I've got a distribution here that says, you know, there's a relationship in it. Maybe I want to do a log transform to correct this. Subpop analysis available in here as well. So we showed that briefly before. And then there's the individual explanations with things like ICE and Shapley that are available too. We also do have a lot of extensions which we don't have here at the moment, but you can go into adding views, and there's things like fairness reports and relationships like that as well, which you can jump down into just to extend the views in the platform.
And Alex was giving answers for general purpose regression. Any type of regression, how do you get explainability out of it? With linear regression, the explainability tends to be very, very simple. You're just looking at the coefficients on each variable there. So if you build a linear regression model you'll be able to see the coefficients and see which ones are predictive very simply. But the tools Alex was showing work for different kinds of regression models as well, random forest regression, XGBoost for a regression model, all sorts of things.
Yeah, 100%. Ordinary least squares, GLMs, yeah, all of the above are available. And obviously, like, feel free to play around with the instances that you've got. You'll see that there's a few algorithms available throughout. GLMs has been added, although maybe not on this particular version that I've got here. But you can also add things like custom Python code as well. There's all sorts of different things that you can play around with. Again, it's a big platform. Have a look at the training. Reach out if you've got any questions. Come see us over the next couple of days at the summit as well. We'll be there in person. More than happy to chat more about all of this.
Absolutely. And I see we're now at time. So thank you everyone for those that stuck around and were able to go through the demo. And I look forward to meeting you at the summit tomorrow. Have a great day, everyone. Bye for now.
Thanks, everybody.